tell me something. Today I'm going to talk about microprocessors.
Yay!
Is Zena going to enjoy this? Okay, let's just have an overview. First I'm going to have an introduction, basically. I'm going to talk about the manufacturing of microprocessors. I'm going to talk about the history of microprocessors briefly. Special purpose microprocessors. We're going to compare the microprocessors to the microcontrollers, and then we're going to have our conclusion. So, first thing, I want to mention that in the olden days, I guess you guys remember Dennis was talking about the old processors. They're not microprocessors, they're made of vacuum tubes. Well, the vacuum tube is kind of big, and even with the, they try to make it smaller, it's still big and, bulky, and this generates even more heat, so it was creating problems, and you guys can guess large core would mean a large device, so this is our old processor. You guys can compare this to the first picture you guys saw, so that's a big difference. That's why it's called micro. It's not really micro, but it is micro compared to this. Let's define microprocessor. Well, the microprocessor is a digital, electronically controlled component that is made of transistors on an integrated circuit. Typically, one or more microprocessors are used as a central processing unit in a computer and handheld devices. I'm sure every one of you has a cell phone, and of course every one of you has a microprocessor in his pocket. Also, I guess my point of this presentation is just to show you how the microprocessor, the industry of microprocessor, the invention has really developed and progressed enormously in just a short amount of time. And hopefully you guys will see that. But first let's talk about how processors are made. And before that I would like to establish 3 facts about sand. First fact is, sand is the second most abundant element in the earth, so we got a lot of it. The second fact is, common sand has a high percentage of silicon in it. That's what we're looking for. And third, silicon can be turned readily into an excellent inductor or an insulator with just an introduction of a small amount of impurity. So we can really make it whatever we want. Now I'd like to mention that this process of manufacturing microprocessors starts in a manufacturer that is different from Intel or AMD, whatever company we're going to talk about. So this is like we're starting in a separate manufacturer, factory or facility. First, we basically bring the sand and we melt it, and then the silicon is purified to 1 alien atom per million. So we don't want really, the purification. The point of it is just to make the silicon do its job and not to make other, atoms interfere with, other elements. Then after that, after melting the sand, we break it into a solid, well, they bring it to a solid state in like a cylindrical shape, and they call it ingot. That's about 12 inches in diameter. Well, after that, we break the ingot, and then we, they cut it into small, circles. They call it wafers. Well, we're talking about a 12-inch thing. You guys can imagine a 12-inch, so it's not really that small, but we're getting it. Wafers are polished to achieve flawless mirror smooth surface. Now at this point, the company, whatever company that is manufacturing microprocessor, buys the wafers from the facility and start, doing the process, which we're getting into it now. Well, wafers go through the process of photolithography. I was trying to think of something to make it, easier to understand. Basically, what it is, you guys can imagine if you want to paint something, and I don't want to really use a lot of time. If you want to paint something and you use, tape, and
a lot like silk screening.
Kind of that, yeah. So you put the tape and then you paint the whole thing, and then you remove the tape, and that's what you want. If you guys can get it. Yeah. So this is basically what they do. They put something called photoresist, and they apply it to the wafer, and then they focus the UV, whatever. I don't want to make it long, but they focus the UV on this photoresist thing, and they make it soluble, so they can remove it later. And then they use chemicals to remove whatever they want from the photoresist, and this is used by mass. Mass is like the tape they use for, you know, making pattern. And now we get to the interesting part. This is the process of ion implementation, aka doping. I'm sure you guys remember from dentist classes. So what they do is they bring either a positive or a negative ions and they impede it beneath the surface. I don't know, I'm feeling like I'm lecturing here, not giving a presentation, but anyways. So they impeded the negative ion or the positive, whatever side they want, the cathode or the anode, and beneath the surface. Now at this point they moved the photoresist that they put earlier. So what we got here is a pattern of, you know, the transistors. Our transistors are built in the wafer. So, and we have tons of them. I mean, like hundreds of millions of billions of such regions in just the wafer. And now we're down to 22. I mean, now currently in 2011 we're down to 22 nanometer of thickness. Now this part is just a small piece of the whole wafer. So they start cutting it to make, you know, small transistors like this. At this point, I thought I would make it faster. So this is just short bullets. So they make they do a process called electroplating, which is basically they put it in a solution of copper sulfate that makes it more conductive. They place a layer of copper to the transistor. Now at this point they bring these small transistors together and they make it whatever the function they want. So like Pentium, AMD, Athlon, whatever. The way they put the transistor together makes the function of the processor and the speed and everything. Wafers go through test steps, so they test the transistors if they are working fine, and then we come to packages. It was kind of surprising to know that, you know, the whole processor it looks like that, which looks small, but actually the actual processor is just a small piece of it. So we're talking about just a small piece, and this package is just for, I guess, heat dissipation and, you know, for the pins to be put, which is we used to, you know, contact with the transistors. Finally, they do the testing for functionality, performance, and power. Okay. Now, I just brought a table here to show you guys the expectation of their, you know, the progress of transistor, you know, manufacturing. Now, we started in 1971 at 10 micro, micrometer. Microns, sorry, yeah, microns is what I mean. So now we're down to 22 nanometers. That's 2011. We're expecting to go to 4 nanometers in approximately 2022. They're expecting that. Well, let's talk a little bit about the history of microprocessors. Well, the first microprocessor released by Intel in 1971, that was the 4004. That's a 4-bit microprocessor. That's like the initial thing. It wasn't really very popular. At the same period also, Texas Instruments TI introduced the TMS 1000, which is another processor, which is, it was just for general purposes for, companies and stuff. They were using it, not really for desktops and people. 1972, Intel introduced the world's first 8-bit microprocessor, which is the 8008. And you guys can see, like, in just 1 year, from 1971 to 1972, we're already progressing in, the manufacturing processors. 1974, just 2 years after that, Intel introduced the 8080, which is just an enhanced version of the 8008. But both of these were, becoming very popular, and they became like the establishment of the marketplace. So they start, making mass production of microprocessor and selling them. 1973, the first 16-bit microprocessor by National Semiconductor, which is another company that used to make microprocessors. We have our first single-chip 16-bit microprocessor. So basically, instead of, semiconductor, the company, what they did, they brought two 8-bit microprocessors and just connected them together to make 16. But instead, TMS, the 9900, just made it one 16-bit microprocessor, which means faster, transfer rate between the memory and the stuff. It's very interesting. I came across Western Digital introduced the CMOS 65816. It was used in the Nintendo Entertainment System, which looks like that. I'm sure all my Saudi friends here have seen this picture before. Me personally, we had 3 at home. I don't know why. But just had 3 for some reason. Too young to remember. Why is that? 1978, the beginning of the x86 family from Intel. Now, I'm really using a lot of time here, but this is very important because this family we're still using at this time. This is like an architecture of, you know, combining the transistors that Intel kind of developed with the help of other companies, but they also licensed other companies to it. It became more effective and less expensive, which made it very popular, and that's why they still, you know, the process we currently use is still from this family. Being cost effective basically played a major role in the success of the 8086, which is the one that, you know, started the family. In 1985, the release of Intel 8286, that's the first successful 32-bit processor. So now we're moving from the 16-bit to the 32-bit. And at the same time now, AMD Advanced Micro Devices, which is, I think some of you have heard of it, released the AM386, which is basically exactly the same as the Intel's 8286. It's just what happened is Intel licensed AMD to use the x86, you know, architecture, and then they start building, and AMD started to get bigger and bigger. Now, this period of time, Intel, AMD, and VSRX started competing and, you know, starting developing because things has got, you know, cheaper and, you know, easy to make. And just for curiosity, how many of you here have heard about VSRX before? Dennis, have you? I'm sure you have.
No, that's a new one on me.
No? Well, I didn't expect that. I expect at least some people. Okay. I don't want to, guys, bore you to death about the history of VSRX. I like this company for some reasons. I guess I'm going to just show you some of it. Basically, they all three started to make, you know, use the x86 architecture and making, you know, processors, and they're becoming more popular and stuff. What happened is, Cyrix, the company, is a very small company. So what happened is, National Semiconductor, you know, got interested in their business, and, you know, I guess the engineers in there, and they kind of merged the two companies. So National Semiconductor kind of bought Cyrix, and they started using the Cyrix. Now got a hand on the, you know, the x86 family. Now Intel didn't feel happy about it, so they really sued them for that. But what happened is they lost the suit because National Semiconductor has some relation with Intel, so they couldn't really get, because you know, National Semiconductor has the ability to use the x86 family, so Intel couldn't really win that suit. So Cyrix kept using the making processors. And what is special about Cyrix, really, microprocessors, they're not really, you know, so fast as like the Intel and AMD, but they were like cheap. They were like really efficient, and they use a very less amount of power than, you know, AMD and Intel. That's what makes them special, because really, you know, they amaze people of how cool their processors are compared to the AMD and Intel. So they were really making some special products, and that's what made them kind of popular at that time. Anyways, in 1992, the beginning of the 64-bit microprocessor era, now we are moving, you know, on into, you know, our current kind of era. 1993, just a year after that, the release of the Intel Pentium and AMD Athlon, which AMD Athlon is my favorite, and I think a lot of people have got the AMD Athlon. AMD, but, you know, the company has really progressed at that time, as like they reached their peak at that time, and that's why I like most, you know, other people felt like they were like, you know, the comparison between the two was like getting that. So really, I mean, AMD has really, you know, gone to the top of it and really started competing with Intel. Even Intel Pentium used to make a lot of heat, and they were like not really that cheap. AMD Athlon was like a bit cooler and, you know, fairly less expensive. And some of you have heard about the Celeron, the Intel Celeron. Most of us have used it because it was kind of less expensive and, you know, kind of popular. Actually, the only reason why Intel would have, you know, produced a line of Celeron is because of, thanks to Cyrix, because they were making cheap processors that people are using, and they were like only, you know, holding to the Pentium and stuff like that, and it was kind of expensive for people. So, you know, people were like trying to go to the Cyrix. That's what we need. And basically, Intel thought of, you know, making a kind of cheap version of their processors, and it was, to be honest, my answer, it was crappy. It was like, it doesn't last for like months, and a lot of heat and problems, and I really didn't like the Celeron by
It
any
was garbage.
measures. Yeah, exactly. So, just last night I thought I would make this presentation a little bit useful. So I added this recently about microprocessors, a slide. Interestingly enough, in June 2006, AMD, now I would like to mention that Cyrix really was sold by National Semiconductor because they kind of distanced themselves from the manufacturer of microprocessors, so they were like left alone, and engineers started to leave by one. And then VIA bought the company, but it still wasn't really, that much successful, so it started to come down. So basically they disappeared. Now Cyrix says, we'll never hear about a processor from Cyrix anymore. But anyways, in June 2006, AMD unveiled the world's lowest power x86 compatible processor that consumed only 0.9 watts. What do you think about this power consumption, Dennis?
Pretty cool, that's pretty low.
Yeah, that's pretty low. And what is the surprise about this Geode AMD version or series of processors? Actually, it was based on Cyrix's architecture. So I guess the credit goes back to the Cyrix architecture, making less power consumption microprocessors, but still useful for daily, usage. Now, also, I just wanted to add this for you guys. If you guys are interested in buying computers, the current Intel microprocessors that are in the market will be the i3, which is more of the budget processor. If you want to buy, you can go to the i5, or if you really want something that is fast and stuff like that, you would go with the i7. AMD, the same thing. AMD just produced recently the Phantom family. They have the X3, which is a triple core. They have the X4, which is quad core. They even have an X6, which is a 6-core microprocessor. And just recently, they made they started again. Actually, it's not a new series, but they started making the FX series, and I guess from the $sign, you guys can guess how much the FX series costs. They're really kind of space numbers, but they're they're used with big companies and servers, and people that really use computer extensively. They would go with the FX series because it's just a blast of a microprocessor. I want to talk about microprocessor in general. Now, the microprocessor is still, until today, the most complex mass-produced product ever, with more than 5.5 million transistors performing hundreds of millions of calculations each second. Numbers are sure to be outdated fast, and I'm sure it was outdated just before, just after I completed my sentence. That's basically two processors, one from Intel, which is the i7, and this is the Phantom. Now, let's talk about special purpose microprocessors. I'm sorry for taking so long. Microcontrollers. We have a microcontroller. We're going to talk about it, so I don't want to spoil the fun. DSP. Basically, it's a digital signal processor. What is used is more in radios and, where you want special, special purpose of the DSP is to process signals. So it's not made for like the computer, the process in this computer, which is made for more of general purposes or arithmetic calculations. We have the GPU, the graphics processor unit, which is used for video cards. So they're made of specifically for more of frame buffer, so they make the image faster. They don't really care more about the calculations. And just yesterday, I have to say it, I discovered there's an APU in the computer, which stands for an accelerator processing unit. This is a new technology that AMD is developing because they bought ATI, which is a graphics company. What happened is when AMD bought ATI, they started combining processor and video cards together, a GPU and a CPU together. So they started making with new technologies, and comparing things. So they're coming with the APU. Or they came up, but it's still in the first phases of the technology. Basically, what happens is the APU kind of help the CPU in its process, kind of make it faster. That's the whole purpose of the APU. Let's talk about a comparison between a microprocessor and a microcontroller. Everyone awake?
Yeah.
Okay. Well, they're the same thing but different. Yeah, like everything else. They are patented. It's patented to Gary Boone and Michael J. Kushran, I think Kushran, from Texas Instrument. this is basically the difference between the microprocessor and a microcontroller. Now, the microcontroller, as you can see here, it is a CPU, but instead of having our memory, which is the cache, I think Dennis talked about it 2 weeks ago, and then the input-output ports, we have them in one package. So the microcontroller is actually more integrated, if I could say that, than a CPU. CPU is just the brain, and then you have to have a memory outside and an input-output port to have your complete circuit. But with a microcontroller, you can just use the one chip that has everything in it.
It's got all the peripherals built into it.
Yeah, exactly.
Describe it.
As I said, microcomputers contain one or more microprocessors, so they use more microprocessors than just one microcomputer to compute the circuit. Now, we're getting to a conclusion here, so everyone, please be happy. Microprocessors are very powerful and are capable, of performing very complex operations at a much faster rate than ever before. New era may begin with the search of new semiconductor alloys, so now they're trying to find something that kind of withstand more heat, and they can put more transistors in it, so they can live longer. And as Dennis said, they're like reaching the peak of how many transistors they can put, so they're trying to find some more other semiconductors, maybe alloys of them. As the demand increases, the need for a solution becomes more urgent, and as they say, the necessity is the mother of invention. Well, I don't think there are any questions, right? You guys have had it?
Good job.
Good job.
Interestingly, most of these guys from it kind of all started in 1947. 3 guys from Bell Labs invented the transistor.
So I'm just saying, yeah.
And a lot of the